Have you ever looked at a math problem, understood every word, knew all the formulas involved, but still had no idea what to do? That moment feels terrible. You try one method, fails. Another method, fails again. Then you start thinking that maybe you're just bad at math. But usually that is not the case. The real problem, in fact, is that you are missing a problem-solving process. So in this video, I'll show you the 3 habits that stop you from missing this process. To begin with, let me explain what we do when we solve problems. What most people do is that they have some knowledge, therefore, they will try to solve. And the solving process, as I mentioned, consists of trying and coming across errors, or perhaps you might just solve the problem in the end. However, in this video, I'm filling in this gap. And the big reveal here is that the step you're missing is understanding. Understanding the problem. I will provide 3 tips in this video on 3 different aspects on how to make your understanding of the problem better. This is what I call a problem solver's toolkit. The reason for which is that knowledge is something you accumulate over time. Solving requires practice and a bit of luck. Understanding the problem, however, is the easiest bit to improve, yet is the most underestimated. However, before we start, I would have to say, welcome to episode 1 of the AMC 12 series. I place this video here because it is the starting point for a good problem solver. In the AMC 12 series, we will focus on knowledge. I will give you an overview of high school knowledge, the formulas, their proofs, and everything apart from that. Meantime, we're going to practice with some problems and practice our problem solving skills. And of course, I would have to mention the biggest highlight of my course, the reason that you should take this one compared to other ones, is because my course is focused on discovery. This is different from other courses. Other courses, they present to you the knowledge, they present to you the formulas, everything you need to know. And some better courses, they will present to you the proofs. Well, of course, I am going to do this. But apart from that, I'm going to explain why the mathematicians first came up with such a notion, and how the process of discovering appeared throughout time to conclude to what we have now, the knowledge system that we build on. So, the target audience of this series is students who are planning to learn high school math or planning to begin contest math by preparing AMC 12. And of course, AMC 10, AMY, these similar contests are also okay. And lastly, of course, it's just those who are interested in just solving some problems and practice their critical thinking abilities. And what you can expect from this course is, of course, first, the knowledge. Secondly, a stronger problem solving ability. And lastly, an entry point into contest math. And that's the introduction for this course. So now let's get back to how to understand the problem. Well, I have to explain this in 3 aspects. First and foremost is concrete understanding, and then intuitive understanding and abstract understanding. The sequence here is by importance, because personally, I think this step is the most important, then it is this step, and then finally it is this step. And the reason that it is more important is because it's going to bring about more change to your problem solving process. This intuitive understanding is the most underrated compared to abstract understanding, which is the least underrated. However, all 3 aspects are underrated. To explain these 3 points, I will explain them through problems. The first problem states that an odd number squared divided by 4 has the remainder of 1. You have to prove this. Try for yourself. Okay, I hope you tried. And the solution is quite simple. You substitute n as 2k plus 1. Then n squared is 4k squared plus 4k plus 1, which is equal to 4 times k squared plus k plus 1. The first part after getting divided by 4 is 0, so the remainder is simply 1, QED. However, there's much more to this problem than the simple substitution and calculations. It is why we took this step. To explain it, let's go through the process of analyzing n and k, because we chose k over n, and why is that so? First of all, let's look at the constraints each variable has. N has the constraint that when divided by 2, it must have a remainder of 1. And also, of course, n is greater than 0. As for k only has the constraint k is greater than 0, and k is an integer. Of course, n is also an integer. And you might notice, going from n to k, the constraints reduced. And meantime, what's even more interesting is we gained two extra numbers, 2 and 1. These two extra numbers provided extra information. Combining these two aspects, it is what I call dissecting constraints. You analyze a constraint, which is n is an odd positive integer. You dissect it, and then you create more information from it, which means you reduce the constraints and gain extra information. Now, with less constraints, it is much easier to analyze the variable. With extra information, you can gain more insights, number-wise. So this is what I call dissecting constraints. This is intuitive understanding. So when you actually get stuck in your problem solving, ask yourself, have I actually unpacked every condition? Very often, the next step is actually hidden inside the wording of the problem. Now, let's move on to the second tool by analyzing problem 2. So problem 2 is selected from AMC 12, 2019, A, problem 9. It is a sequence problem, and you have to find the 2019th term. Try it. Now, I'm suspecting that some of you got stuck in this problem. And since you got stuck, you might have tried to dissect the constraints. Well, let's look at this. Unfortunately, I don't see anything clear here. The first method doesn't really work. So what do we do? Well, since we know a1 equals 1, a2 equals 3 over 7, then we can find a3. a3 is simply a1 times a2 over 2 times a1 minus a2. That said, we can calculate a3. And if you calculate this yourself, you realize that the answer is simply 3 over 11. We can continue this. a4 is equal to 3 over 15, or 1/5. And then a5 is 3 over 19. Have you observed a pattern here? Well, yeah, there's a 3. There's also a 3. 3 for everyone. And of course, we can rewrite a1 as 3 over 3. So indeed, 3 for everyone. From this, we can guess the conclusion. an is equal to 3 over 4n minus 1. How do we verify this, though? Well, it's not hard, because you can represent an minus 1 and an minus 2. Now, just plug all of this back to the original recursive equation. If the equation always holds true, then our guess is correct. In fact, you can verify this yourself. This is true. That means the answer of the problem is simply 3 over 8,075. And we're done. Again, we should probably analyze what happened here. Well, it's actually kind of simple. We listed out a few terms, what we did here. And that decided how we solved the problem. What happened? This is what I call concrete understanding. We have concrete examples. And then after that, it is our toolkit, observing patterns. This is the second tip. This is exceptionally important because basically in every single hard problem, when you're stuck, you can just try some special values, try some special cases, try a certain case like 1, 2, 3, 4, 5, and then you would gain a pattern, possibly, if the problem is designed so. A lot of students do, in fact, skip this step. because they think this is not standard problem solving. However, in real problem solving, you don't always derive results. You guess results and prove them. This is what a good problem solver does. So after that, let us move on to problem 3 and the third tip. So problem 3 is from AMC 12, 2023, problem 17. So not an easy problem. Let's see, how are we supposed to solve this? Triangle ABC, let's draw it, has side lengths in arithmetic progression. And the smallest side has length 6. If the triangle has an angle of 120 degrees, we can assume it is this. What is the area of triangle ABC? Now, in fact, this problem is solvable with middle school math, so you can try it for yourself. But if you use high school math, it's going to be a lot simpler. Take a moment to solve it yourself. Okay, so first, we probably have to determine whether AC is greater than BC. And by drawing the graph over here, you have a concrete example, so you can guess it is true. That is exactly a concrete understanding of the problem. In this case, in fact, it is true, which can be proven by the law of sine. We'll explain that in the future. Then we are now to deal with this constraint I highlighted here, arithmetic progression. How are we to unpack this information? Well, you probably did one thing, which is you set the common difference as x. Then BC becomes 6 plus x, and AC becomes 6 plus 2x. Once you arrive at this conclusion, now you can apply law of cosine, which states AB squared plus BC squared minus 2 times cosine angle of B times AB times BC is equal to AC squared. If this seems like a mess to you, don't be afraid. You will learn how to do this simply in the future. It is not hard to understand. And then with this, since we only have the variable x, we can solve for x, and then we can gain our answer, because the area of ABC is 1/2 of AB times BC times sine angle of B. And then we're done. So this problem requires a bit of heavy calculation, so I won't go through the details, but the full solution, along with all the notes of this lecture, will be down below in the description. Be sure to check it out. So what did we do here? Well, we first came up with x. This is a variable. Then we came up with representations, represented BC and AC. Finally, we used the law of cosine, which is forming an equation. And through this process, we successfully managed to solve the variables, and thus we successfully solved the problem. And this is what I call abstract understanding. And it is basically concluded as representing relationships. This is important and sometimes forgotten because a lot of you tend to solve from the beginning with the constraints and then try to go one step further, further, further. And every single step, you try to solve all the variables or everything you want to know before you move on to the next step. However, note what I did here. I first determined which is the longest length, which is unpacking information. Okay. Then we wrote this equation and then this equation. So in fact, this is from two completely different steps. You could have solved x here, but I first tried to determine what is the area, because looking at the area will tell me whether I need to solve for x, or we only need 6 times 6 plus x, for instance. Because in case this thing simplified down to 6x plus 36 is something, you can just plug it directly in. That is going to save some time for you. And for other problems, sometimes you might end up with a crazy position. Like, I don't know, for instance, you might get this. You might have a certain value here. Let's say a is a constant, and then you might try to solve for x. That's whopping hard. But perhaps the problem is just asking for this. The problem didn't ask for x. Then you just plug in a, which is enough. So The true power in representing relationships is to represent everything first and then solve from the beginning step by step down. And this is also very important and very, very commonly forgotten. So that concludes all 3 points that I'm trying to give today. But before we end the video, there is something more. Since you watched 20 minutes into this video, you're probably very interested in learning some math. So if you're actually interested, stay for a few more minutes and I'll explain how the course is going to go. First of all, the course consists of 20 videos, which is going to be released over 40 days. The first video is already done. I am trying to give you an overview of how you solve problems. From video 2 to video 17, a total of 16 videos, I will give you the sufficient knowledge by covering everything in high school math that is needed. And then finally, video 18 is a conclusion of video 2 to 17. And finally, we have video 19 to 20, which are 2 mock tests for AMC 12 that I crafted myself. And I think they are a reasonable prediction of 2027 because, in my opinion, 2027 AMC 12 is not going to be that easy compared to the past. So I think the mock tests are actually very valuable as well. This is the course schedule. There are other details like problem difficulty in this course. You can check it down below in the document in the description. And similarly, in the future videos, um, all the notes of the class will be given to you in the description. So don't worry. So a quick overview of the video. Here's the checklist I want you to remember. Translate the conditions, create the data, and then represent the relationships. After you do these things, I hope you good luck in solving the problem. So in the next episode, we will start building the actual mathematical tools, algebra, geometry, number theory, combinatorics, and more. But before formulas, we need thinking, because the goal is not just to solve the problem. The goal is to become the kind of person who knows how to attack problems they have never seen before. And this is Axes Math Lab. And I'll see you in the next episode. Don't forget to subscribe and drop a like. Peace until then. Bye.